Hello, and thank you for tuning in to this lesson of adding integers, day one. All right, so we're going to start with some material in class that may have been a little bit hard to chew. It may have been a little bit hard to digest, and I'm going to walk through it with you here in a little bit slower fashion. Remember, always hit pause when there's something that you want to write down, and unpause it when you're ready to continue. All right, how do I add integers with the same sign? So let's just quickly take a brief recap to the other day and talk about what an integer was. What was an integer? You don't have to write this down, but I just want to quickly remind you that an integer is any whole number and its opposite. So in this case, we are not talking about fractions and we are not talking about decimals. No fractions and no decimals. We are not talking about either one of those. We're talking about the whole numbers that we count with, 1, 2, 3, 4, 5. The opposites are the negatives, and then 0. So that's what we're talking about. How do I add these integers when they have the same sign? When I'm talking about a sign, I mean the positive or the negative sign, telling me on what side of the 0 line do these exist. Additive inverse. Additive inverse is a property that allows us to add the sum of any number and its additive inverse is 0. It's the sum of any number and its opposite. So if I have the number 5, its opposite is negative 5. And when I add it together, it is 0. So 5 and its additive inverse, in this case, the additive inverse is negative 5 because the total is 0. If I had negative 7, plus what number would equal 0? Well, if I'm on a number line and I am at negative 7, where do I have to go to get back to 0? I have to go 7 places. I have to go in the positive direction. So I need a positive 7. Its opposite. Any sum and any number and its opposite are additive inverses of each other. There are some examples, and we'll throw the algebraic example in here because this allows us to plug any number in. I could tell you that x equaled 10. And if I told you that x equaled 10, then I would have 10 plus a negative 10, and that would equal 0. I could tell you that x equaled negative 13. So I'd have a negative 13 plus a double negative, which we'll talk about later. And in this case, it turns out to be negative 13 plus 13, and that would still equal 0. So additive inverse is a number that you add on to another number to make it equal 0, or its opposite. All right, so let's talk about how we add these numbers together. Adding numbers with the same sign is actually fairly easy, but we're going to start with a story here. I will read it to you, and it'll help us later on when we're discussing other things in class as well. In a far-off land, there was once a team of amazing chefs who cooked up the most wonderful soups ever imagined. They prepared their mixtures over a huge cauldron, and their work was very delicate and complex. During the cooking process, they frequently had to change the temperature of the cauldron in order to bring out certain flavors and cook the soup to perfection. So they would put in these hot cubes, and they would put in these cold cubes. And as always, in a far-off land, these are magical hot cubes and cold cubes. They adjusted the temperature of the soups either by adding special hot cubes or cold cubes to the cauldron, or by removing some of the hot or cold cubes that were already in the cauldron. The cold cubes were similar to ice cubes, except they didn't melt. And the hot cubes were similar to charcoal briquettes, except they didn't lose their heat. So once I put in a hot cube, it stayed warmer. And if I put in a cold cube, it stayed cooler. It didn't melt, it didn't lose its power, it didn't lose its temperature. If the number of hot cubes in the cauldron was the same as the number of cold cubes, the temperature of the cauldron would be So think about that for a minute. If I had a pot of soup and it was a certain temperature and I put 2 cold cubes in here, my soup would get colder. And if I put 2 hot cubes in there, it would get hotter. But in all, what would happen? The temperature would end up being the same as it was to start, because this hot cube and this cold cube would cancel each other out. This would bring it down 1 degree, but this would bring it up 1 degree. Together, these would bring it down 2 degrees, but together, this would bring it back up 2 degrees. For every cold cube put into the cauldron, the temperature would lower by 1 degree. What do you think would happen if I took out a cold cube? So this current temperature here was 3 degrees colder. If I took one out, it's only 2 degrees colder. Think about what happened to the temperature of this soup. Overall, the temperature of this soup would get warmer. What happened to the temperature of the soup if I put in 5 cold cubes? So I have soup, and I'm going to put in 5 cold cubes. Pause if you need to think. But the temperature of the soup would get 5 degrees colder. What would happen if I put in 8 hot cubes? Pause if you need to. My temperature would get 8 degrees hotter because I put in 8 hot cubes. What would happen if chef number 1 walked in and said, "This soup is not right. In order to make this soup right, we need to add 5 hot cubes." So chef number 1 came in and he added 5 hot cubes. Altogether, what would happen? Well, this would be 5 degrees hotter. However, chef number 2 walked in and said, "No, you have it all wrong. We need to add in 7 more hot cubes." So he added in 7 more. 1, 2, 3, 4, 5, 6, 7. What happened here? Not only did I have the 5 hot cubes from before, but now I have 7 additional hot cubes. And all together we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. One of them is hiding somewhere. Oh no, 12. We have 12 hot cubes. Sorry, I had the wrong number in my head. We have an additional raising temperature of 12 degrees because of those 12 hot cubes. So how could we represent that? This would be like adding in 5 hot cubes. The hot cubes are positive, and I put them in. And then I'm also going to add in 7 hot cubes. And what happened at the end? At the end, altogether, I had 12 hot cubes. So looking at this next one with numbers, can you represent this problem with numbers? Chef 1 put in 4 hot cubes, and Chef 2 put in 2 hot cubes. Pause it, try it, and then come back. So if I'm going to put in 4 hot cubes, I have 4 hot cubes and 2 hot cubes. I'm going to add them into the soup. Let's see if these numbers worked out. 4 hot cubes is what Chef 1 did. 1, 2, 3, 4. And then 2 hot cubes is what Chef 2 did. 1, 2. So 4 hot cubes plus 2 hot cubes is a total of 6 hot cubes. 1, 2, 3, 4, 5, 6. A total of 6 degrees warmer. Again, hit pause, come back when you have the answer to this. Chef 1 put in 3 hot cubes. Chef 2 put in 9 hot cubes. We added them all together, and we got a total of 12 hot cubes. A positive 3 and a positive 9 added together is a positive 12. What happened if Chef 1 put in 10 hot cubes and Chef 2 put in 7 cold cubes? Can you represent this with numbers? So now I have Chef 1, he's putting in 10 hot cubes. 10 hot cubes. Chef number 2 is going to put in 7 cold cubes, and we're going to add it all in together into the soup. So that is just representing in numbers what is going on. I don't want the answer yet, just represent with numbers. Go ahead and hit pause. Try this one and come back. Alright, hopefully you found that Chef 1 put in 8 hot cubes, so it's a positive 8. My integer is a positive 8. Chef number 2 added into the pot 15 cold cubes. That's represented in numbers. I'm not going to solve it from here. That's not what we're practicing right now. But we do have 8 hot cubes and 15 cold cubes. Pause it and come back. All right, in this case, we have 17 hot cubes plus 9 cold cubes. All right, so how do we get an answer here? What's the final answer going to be? What happened if Chef 1 came in and put in 7 cold cubes and Chef 2 came in and put in 4 hot cubes? So I have 7 cold cubes. I have 4 hot cubes. Chef 1 put in 7 cold. Chef 2 put in 4 hots. I'm going to represent that here. 7 cold. 1, 2, 3, 4, 5, 6, 7. By doing that, Chef number 1 made this soup 7 degrees colder. Chef 2 came in and said, oh, no, no, no. We have to put in 4 hot cubes. These hot cubes canceled out those cold cubes and made them even. So what is left over are these 3 cold cubes. Overall, we're left with 3 cold cubes. The cold cubes were left over. Try this one on your own. Hit pause and then come back. Chef 1 put in 5 cold cubes. Chef 2 put in 14 hot cubes. So if I had 14 hots, which may not fit in my bowl here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are my 14 hot cubes, and I'm going to put in 5 cold cubes. 1, 2, 3, 4, 5. What do you notice? I notice that there are more hot cubes left over. How many hot cubes are left over? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 hot cubes left over. After a few examples like this and a few examples in the class, you're probably going to notice a pattern. But the answer here is positive 9. Pause it and then come back. All right, Chef 1 put in 15 cold cubes, 15 cold. Chef 2 put in 14 hots, 14 hots. So I want you to think to yourself, what do I know about each hot and each cold? I know they're going to cancel each other out. They're going to make the temperature even. So I have to think, what am I going to have more of in this pot? Am I going to have more colds or more hots? Well, I have 15 cold cubes, 14 hot cubes. That means I have more cold cubes. By how many? 1. Hit pause and then return. So at first I have 2 cold cubes. I have 5 hot cubes. What do I have more of in my pot? I have 5 hots and 2 colds. I have more hot cubes. How many more hot cubes are there? 3. Do you see the pattern yet? I hope you're getting close. So let's talk about your pattern. What patterns did you notice? I noticed that my final sum was either positive or negative. Depending, whoops, I'm running out of room there, I apologize. Or negative, depending on the larger absolute value of the 2 digits. So what does that mean? Let's go back to this one. Negative 2 plus positive 5. That was one of the last ones we did. if I happened to have taken in my head the absolute value of -2, I would have had 2. Remember, it's the distance from 0. And the absolute value of 5 would have been 5. This 5 has a bigger absolute value, so my answer shared that sign. All right, so another way that we can look at it is this. If I'm going to add integers with the same sign, I can think of my negative and positive chips, or my negative and positive tiles. I have 7 negatives, 1, 2, 3, 4, 5, 6, 7. I'm going to add in 3 negatives, 1, 2, 3. 7 negatives and 3 more negatives make a total of 10 negatives. I could also show that on a number line. If I started at 0 and I needed 7 negatives, I would have to go this way 7 times. And then if I had 3 more negatives, I'd have to go 1, 2, 3 for a total of negative 10. All right, what if they were all positive signs? 5 positives plus 4 positives is a total of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I can also show that on the number line. If I start at 0, I want a positive 5, I go to the 5, and 4 more, 1, 2, 3, 4, brings me to a positive 9. So you try this one. Once again, hit pause, use the number line if you want to, or draw your symbols, and then come back. All right, in this case, I'm going to draw some symbols for you. I'd have 8 negatives right here. I want to add on 2 negatives. On my number line, I'd go to 8 negatives and then add in 2 negatives. Or in my soup, I'd put in 8 colds and add in 2 colds. And altogether, I would have 10 negatives. Negative 10 is my answer. All right, let's look at this one. If I'm going to start at 0 and go to 7, add 3 more, I go to 10. Add 4 more, I'm off my number line, but the answer is a positive 14. 2 plus 3. Again, representing this as 2 positives and 3 positives, and at the end, it's 5 positives, which you already knew, but sometimes it's nice to work with smaller numbers so you can see the pattern. -3 plus -6. I have 3 negatives plus 6 negatives. So altogether I have 9 negatives. On a number line, I'm starting at 0, working my way to -3, and then I'm going to add in 6 more. 1, 2, 3, 4, 5, 6. Once again, which brings me to -9. Same idea here, even with more than 1. I'm starting at 0. I'm going back 1, then back 3, 1, 2, 3, and then back 5, 1, 2, 3, 4, 5. My final answer is -9. If I thought about the chips, the tiles, the cubes, it could be 1 cold cube, 3 cold cubes, 5 cold cubes. Altogether, 5, 6, 7, 8, and 9. Go ahead, hit pause, and see if you can solve this one. Hopefully you were able to notice that I have to replace this A with a 5, replace this C with a 7, and just add. 5 plus 7 is 12. D, B, D. B is -2. D is -9. So this would be -9 plus -2 plus -9. This would be 9 negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 2 negatives, and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to make this an even 10, so I'm going to take this here and take that there, so I have a total of 20 negatives. Again, hit pause one more time, solve these, and come back and see if you have the right answer. -23, positive 36, -22. Did you get them? Good job. If not, we'll keep practicing. All right, so here we are with some real world problems, some story problems. We have Emma. Emma babysat last week. She earned $10 one day, $5 another day, and $7 another day. How much money did she earn from babysitting? Our integers are a positive 10, plus 5, plus 7. 7 plus 5 is 12. 12 plus 10 is 22. She made a total of $22. Jim bought lunch for $11 and then went and bought ice cream. How much money did he spend? He spent $11 for lunch, $5 for ice cream, for a total of $16. In summary, summary number 1. When you add same signs, just add the numbers and keep the sign. It's very simple because I'm living in that world, either of all positives or of all negatives. I know some of our examples had positive and negatives involved, and we'll talk about that in a few days. But right now, we had it all the same sign. Once again, if you need some additional assistance, Khan Academy has some great resources for you. And then you can just type in same sign integers sum. Same sign integer sum. Or sum of integers with the same sign. But those would be some good keywords for you. I hope you were able to pick up on anything that you may have missed out on in class, or if you were absent, that you were able to learn the lesson that we have so you are not too far behind. We hope you have a great day.